Hi there. In today's video, we are looking at question 3, which is an analytical geometry problem from the 2024 November paper 2 maths exam. Okay, let's get straight into it. So we've been given a diagram with triangle ACD, and it has the vertices A, which we don't know the coordinates of, D down here, and C over here to the left. And A is a point in the second quadrant, and we don't know the y coordinate of point B. All right, let's get into the questions. So 3.1 wants us to calculate the gradient of DC. So this is line DC, and we see that we've got points C and D. So we can use these to calculate our gradient. 3.1. So gradient of DC is equal to y2 minus y1 over x2 minus x1. So we can make point C 0.2, so that would be the y value, which is 0, minus the y value of D, which is -9. And then the x coordinate, that's -9. And here we've got 3. Oh, my 3 is looking weird. My negative sign, sorry. Okay, so now we've got +9 over -12, which simplifies to just -3 over 4. So that's the gradient of line DC. In 3.2, they ask us to determine the equation of that same line DC. So now we can pick one point to substitute in. I'm going to pick C because it has y being 0. So let's do that. So 3.2. We know the equation of a straight line is y is equals to mx plus c, and I'm going to substitute point C, which has x being -9 and y being 0. So substituting this coordinate and our gradient, we've got 0 is equals to -3 over 4 multiplied by our x, which is -9, plus c. So now we're solving for C. And we find that everything goes to 0, and we get a C value of -27 over 4. And we can convert this to a mixed fraction, which gives us -6 and 3/4 as our value for C. But I'm just going to work with the improper fraction. Okay, so now we have everything, so that means the equation of the line DC will be y is equals to -3 over 4x minus 27 over 4. And that is our equation. Moving on to question 3.3. They said that we should show that k is equal to -6. So we see that k is this point, well, it's on point B, and it's a y coordinate. So we just need to substitute our x value and see what the y value is, because we now have the equation for line DC. So B has, I think it's -1 and k. And then we substitute the x. So y will be equal to -3 over 4 multiplied by -1, and then we subtract 27 over 4. And we get a y value that is equal to, that's just now +3 over 4 minus 27 over 4. And putting that in your calculator, you do actually get -6 indeed. So we can therefore say k is equal to -6, and that is our solution. 3.4 is the next question. They want us to calculate the length of DC. Still with line DC. Okay, so length is the distance equation. So we're going to use the distance equation. So d of DC will be equal to x2 minus x1 squared plus y2 minus y1 squared. Okay, and this will be equal to, so now we substitute our points. So it's exactly the same points. So x2 in our previous calculation, we made that -1, -9, which was for point C. So it's -9 now minus 3. So -9 minus, this one is, I think it's a +3, yes. Minus a +3 squared. The y here, I think it was 0. And then minus, for D, it's -9. Okay, simplifying further, now we've got -12 squared plus, this is now just a +9 squared. And you get, this is 144 plus 81. And putting this in a calculator, you get an answer of 15 units. Because it's distance, so we always need to put units. Okay, nice. Now we need to move on to 3.5, and here we are calculating the ratio of DB to DC. Now we just calculated the length of DC, and now we need the ratio of DB over DC, meaning we also need to get the length of DB. Now remember, B was the point where we calculated its y coordinate, and we found it to be -6. So we can actually now calculate the distance for DB. So let's do that calculation. 3.5. We need the distance of DB, which will be equal to, so I'm not going to write the equation again. I'm just going to substitute directly. So point D is the one that's the one with 3 and -9. So B, its x is -1. So here it would be -1 minus 3 squared, and then plus, and the k is -6 minus -9. And this is also squared. Okay, now this then simplifies to inside -1 minus 3, that's -4 squared. And here we've got -6 plus, I don't know what's going on with my, keep zooming in and out. -6 plus 9 gives you -3. Now this is 4 squared plus 3 squared, which should give you 5. Because this is just the square root of 25. And there we go, 5 units. Now they want the ratio of DB to DC. So we are looking at DB over line DC. And DB, we calculated it to be 5 units. DC, we calculated 15. So you actually see that 5 there, and then 5 goes into 15 3 times, so you end up with 1/3 as the final answer for the ratio of dB to DC. Okay, nice. Let's move on to 3.6. If M is a point on AD such that AC is parallel to MB, calculate the ratio of area of triangle MBD over area of triangle ACD. Okay, this sounds very familiar to what we do in Euclidean geometry. So M is just a point on AD that allows AC to be parallel to MB. So let's find AC, and then we want a line parallel to that one. So I'm going to use my ruler just for the sake of sketching. And it should be parallel. So let's put it over here. No, but that's the y-intercept. Don't want it to be seeming like I picked that point. Okay, I think this is better if we put it over here. Now joining, I still need my ruler. Let's move it a bit. I think that's fine. There we go. So this is my point M that I just randomly chose, and this is the line. Wait, I think I'm missing something. MB. Oh, it should connect to B. Oops. Okay, so if it's parallel and it's connecting to MB, that means just keep it like that. There we go. So that means it's in the actual right position. Okay. So now we have MB, which is parallel to AC, and we don't know the coordinates of M. All right. So now we need to calculate the ratio of the areas of the two triangles. Okay. Now, what we can do is, earlier on, we calculated the ratio of dB to DC, which was over here. So that's DC in green. I can highlight dB in purple, like that. So that means, since these two lines are parallel, I can pick a bright color. According to the proportionality theorem, the ratio of dm to dA should also be equal, right? Because AC is parallel to MD. So now we're going to be using the proportionality theorem. So dm to dA will be equal to dB over DC, which is equal to 1/3. And this comes from the proportionality theorem, because we know that AC is parallel to MB. Okay, so according to the proportionality theorem, if the sides are proportional, the areas will also be proportional. So that means we can get the ratio of the areas, right? But we don't have the areas, and we know the equation of area is half base times height, but you need a perpendicular height, and we don't have that. We don't have any information to get that. But what we do have are two sides and angles that are shared by these two triangles. They share this common angle over here at D. And we are looking at proportionality of these sides. These ones and these ones. So we can use the area rule because we can see that the sides that we are looking at are proportional to each other. So that's the little hack we're going to use. So now to use the areas, which one's on top? MBD and then ACD. So the area of triangle MBD over the area of triangle ACD will be equal to half, and then it's one side, so here it will be, we'll pick DB for the small triangle and DM, and then the angle between, which is angle D, according to the sine rule. So DM and side DB, sine angle D. And then we'll do the same with the bottom triangle. So now we're looking at side DC and side DA. So let's start with DA since that matches with DM, and then we'll write DC since that goes hand in hand with DB. And it's still the shared angle sine D. And here we are using the area rule. Okay, so our halves cancel. So I'm going to change colors so that you can see what I'm doing. The halves cancel and the sine D's cancel. Now look what we have. We've got DM over DA once again, multiplied by DB over DC, which are the two sides that we found to be proportional earlier on. And we know that they're proportional, meaning that they have the same ratios. So now we can replace them with their ratios. So here I can put 1 over 3. And here for DB, I can also put 1 over 3. And that then ends up being 1 over 9. And that is my solution. So here the trick was to apply the proportionality theorem because we were told AC is parallel to MB. And because we don't have any perpendicular height, but these two triangles do have a common angle, which is angle D, we're then able to use the area rule to calculate our area. And we picked sides that we already had the ratios to. We already have the ratios to all of them because of the proportionality theorem. Okay, now let's move on to question 3.7. The last question. So we are told that it is further given that the gradient of AD is -4 and the length of AD is this, square root of 612. And they want us to calculate the coordinates of A. Interesting. So let me erase this. So we are now looking at AD. You can highlight it in orange. It's this one. So we have the gradient and we know the distance or the length. It's the square root of 612 units. Okay, So now we're looking for the coordinates of A. This is what we need. We have the length and we've got point D. So automatically that's telling us that we are going to have to use the distance formula. But remember, a coordinate is made up of the x value and the y value. So that means we've got two unknowns in our distance equation. So that means we need a second one. But we've been given the gradient, right? We know the gradient is equal to -4. We've got 1 point. So that then reduces our unknowns, and we can solve these two equations simultaneously. So let's do that. Let's start with calculating the equation of the line. I think that would be the easiest. So line AD, M is equals to -4, and D, the coordinates, I keep forgetting the coordinates of the D. It's 3 and -9. Okay, so equation of a straight line, y is equals to mx plus c, and then we substitute our m and d. So here we have -9 is equal to -4, x we put the 3, and we want c. So this is -9 is equals to -12 plus c. And c, we can see, see what I did, is 3. Alright, now we have that. So that means our equation of line AD is thus y is -4x plus 3. Okay, I don't know what happened to my x. That was not a joke. No pun intended. Okay, so now we've got the equation of our line AD. Now we can apply the distance formula. So let's consider this equation number 1. Okay, and I'm not rewriting the distance equation because we've used it a couple of times. So now I'm just going to say D of AD will be equal to, actually, let me just substitute the length of AD. We know it's the square root of 612. And then here, we will subtract A. So we'll make D our x2. So here we'll have 3 minus, okay, now this is looking messy. Okay, back here, 3 minus x2, or let's call it xa, since we know we are looking for A, squared plus minus 9 minus ya squared. This is what we're solving for. I'm just looking at this. I don't like working with negative. I think let me swap the order. Since we are looking for the x and the y, let's put those first. So it would be x a minus the 3. And then y a minus the minus 9. Order doesn't really matter as long as the order of your x and your y match. Okay, so now we've set up our distance equation. Now we can simplify. So we're going to square both sides to get rid of the roots. So that leaves us with just 612 being equal to the x of a minus 3 squared plus the y of a minus, which becomes a plus 9 squared. Now it's time for algebra. So 612 is xa squared minus, well, minus 3 becomes minus 6. Xa and plus 9. And then the second bracket, this is YA squared plus 18YA, and then this is 9 times 9, which is 81. Okay, so you can see that I have my two brackets expanded. Okay, so this then becomes equation number 2. I know it looks intimidating, but trust me, we've got this. So where we see y, we're going to replace it with equation number 1. So now we're going to say substitute 1 into 2. Let's pop up. Okay, so where we see our YA, we replace with the equation of y. Because remember, y is the y coordinate of our point A. So we can actually replace it with the equation of the line. So that once we get the x value, we will be able to get y. So let's do that. So 612 is equals to xa squared minus 6xa plus 9 plus, here we've got minus 4x plus 3 squared plus 18 minus 4x plus 3. Okay, this question is long. Plus 81. Okay, now it's time to just simplify. And at least now we've got our x's. I do want you guys to remember we're dealing with the same x. So what I'm going to do is I'm going to, I think since we know we're solving for xa, all these, let me make the highlighter bigger. I'm going to just label them as x for the sake of simplicity. So now this is just going to be 612 is equals to x squared minus 6 x plus 9 plus. Now let's expand this bracket. 4 and 4 is 16. Don't know why that took them so long. 16x squared. And then 4 and 3 is 12. So minus 12 minus 12, which is minus 24. And then 3 and 3 is 9. Okay, plus 18. Okay, here we can actually just multiply it in. So 18 times negative 4, you get negative 72. X, and then 18 times 3 is plus 54. And then here we've got plus 81. Okay, now it's just grouping like terms. Let's keep the 612 there for now. So the x squared and this, and that's literally it. So 16, that plus 1 is 17x squared. And then next we are looking at, let's highlight it. We can use a green. 6x and 24x and negative 72. So that's negative 6 plus, well, it's negative 24 and negative 72. We get negative 102. X. And then we are looking at 9, 54, 81. So 18 plus 54 plus 81. Okay, it's 153. Okay, now we can take the 612 to the other side. So now we've got 17x squared minus 102x, and then minus 459 being equal to 0. When we take 612 to the right, well, in this case, to the left. Okay, so now we just need to solve for x, and here we can use the quadratic formula because some people probably can factorize this, not me. So x will be equals to negative b, which is negative 102 plus minus b squared minus 4ac all over 2a. And simplifying this, you end up with x being equal to negative 3, or x is equal to positive 9. Okay, so now we have our two x values. We now need to see which one matches, because we remember we're looking at point A. So point A is in the second quadrant over here, so it makes sense that x would be a negative value. So it cannot be 9, right? Can't be 9. So now if we know x is negative 3, we can now substitute that into equation 1 to get the y value. So therefore, y is equals to negative 4, substituting x, I think it was plus 3, yeah. And here we get y is equal to 15. So therefore, wow, we finally reached the end. The coordinates of point A are going to be x is negative 3 and y is positive 15. And that is the final answer.